Hi friends, greetings. I want us to look at this projectile, and according to the path, you can see that the path is parabolic, right? So, and the launch speed is given as u, and this component that helps to carry the particle upward is given as u sine theta, because if you resolve this component, it's the angle theta, that's the angle of projection, and the horizontal component is given as u cos theta. Great. Now, this vertical component is given as u sine theta, and like I said, this is the launch speed or the launch velocity. Now, I want us to get the maximum height. Now, I want us to get two things. I want us to get the maximum height, that's the height from the ground level, the highest possible height that the projectile could attain. And I also want us to get the time taken by the projectile to attain this maximum height. I also want us to get the total time taken for this projectile to leave from the launch path till when it reaches its final destination. And from this trajectory, we could see that there is a clear symmetry. There's a clear symmetry between, I can call this zone N, and this one zone N as well, because there's a clear symmetry, because the area from here to here is same as the area from here to here. So this is like a quadratic curve. So without further waste of time, let's dive straight into it. Using one of the laws, one of the Newton's laws of motion, we could say that S is equal to ut plus 1/2 gt squared, where this S is a distance, u is the initial velocity, t is the time taken, and g is the gravitational field strength. Wait. So now, our aim in this first case now is to find the time taken for this projectile to leave its initial position till its final position. And we know for sure that when the projectile leaves its initial position, that is at this point 0, it travels and reaches at the same point its y displacement, that is a vertical displacement, still is what? 0. So I can set this guy equal to 0. And knowing fully well that the time taken for the projectile to finally reach its final destination depends on the vertical component of its velocity. And that component has value what? U sine theta. So I'm going to say that if this projectile reaches its final destination, this S is equal to 0, and we know for sure that the initial direction of projection is upwards, meanwhile gravity acts where? Downwards. So I can say that as the projectile is from here and it is going, it is slowing down. That means that what? It is opposing gravity. So I will take upwards as positive, downward as negative, such that this g tells us what? Negative g. So without further waste of time, I'm going to set S equal to 0. That's 0 is equal to my u in this case now is what? U sine theta. That's u sine theta t minus, since my g is negative, minus 1/2 gt squared. Wait, this is quadratic. If I set everything to the side, I'm going to have, and I multiply all through by 2, I'm going to have gt squared. Thus, I'm going to have gt squared minus 2u sine theta t equal to 0. So in this case now, I'm going to factor out t. I factor out the time. So I'm going to have t into gt minus 2u sine theta equal to 0. So I have my first time t to be equal to 0. This t equals 0 means that the projectile is still at its initial position. Yes. So if I solve this other one, I'm going to have gt minus gt, I'll send it this way, equal to 2u sine of the angle theta. That implies my t is equal to what? 2u sine theta all over g. Perfect. So this t equals to 2u sine theta over g is the time taken for the projectile to leave its initial position and arrive at its final position. Assumptions, one of the assumptions I can take is that air resistance in this case is negligible. Perfect. That's the first proof. And this t is the time taken for this man to leave from here to here. Now the time taken to attain its maximum height is just half of this due to the symmetry. Okay? Yes. So that's it. So now I also want to get the horizontal range of the projectile. The horizontal range tells me the maximum distance from the initial position till the final position. I can call that range R1. And still using Newton's law of motion, S equals to ut minus 1/2 gt squared. I see that the horizontal component of the speed is not accelerated. It is not accelerated. That means that this g in this case turns out to be 0. That implies, and this s is my range, that's r. So r turns out to be what? Ut. But what is my u? My u, the component of the velocity that helps the projectile to attain its maximum range, is u cos theta, and it is constant. It is a constant component. So I'm going to have r to be equal to u cos theta. What is t? T is the time taken for the projectile to leave from its initial position till its final position. So it is going to be times, and we got it initially to be 2u sine theta all that on g. As I see 2 sine theta cos theta, it is what? It is sine 2 theta. And this u times gives me u squared. So I'm going to have 2